Hello and welcome back to the course. In today's lecture, we are going to look at a numerical problem based on volumetric efficiency and free air delivery. Before taking up the problem, let us list the equations which we have derived in the previous class. So in the previous class, based on the PV diagram, we have defined volumetric efficiency as shown here, and further by plugging in the volumes, corresponding volumes, we have arrived at a final equation for volumetric efficiency as shown here. In this equation, the C corresponds to clearance ratio, which is a ratio of clearance volume to that of swept volume. Further, one can express this volume ratio in terms of pressure ratio using a polytropic equation, and the equation can be expressed as shown. And then we took up a discussion on free air delivery, and we have expressed an equation for that as shown here. And further, V1 minus V4 we expressed in terms of pressure ratio, and the equation for the overall volumetric efficiency is shown here. Now let us look at the problem. We have a single stage, single acting reciprocating air compressor, bore and stroke given to us, and the compressor is running at 600 rpm. Clearance volume is given to us, initial conditions with reference to suction, and the ambient is given to us. The free air delivery, overall volumetric efficiency, and indicated power are the parameters to be worked out. Now let us move ahead. Let us list the given data, and the data that can be extracted from the given problem is as shown here. And let us now plot the PV diagram for the given problem. It comes to as shown. We have a pressure ratios here, P2 and P1, and the clearance volume is shown to be as 0.4 to that of the swept volume. Now calculating first the free air delivery, we have a straightforward equation, and in this equation we know temperatures, pressure related to suction and ambient. However, V1 and V4 are the volumes which we are supposed to calculate. V1 corresponds to the total volume, therefore V1 is equal to clearance volume plus swept volume. Further, V4 corresponds to a volume which can be worked out based upon the polytropic equation as shown here, and using PV diagram, P3 can be expressed as P2 and P4 can be expressed as P1, since they are constant pressure process. Therefore we have a equation or volume ratio as shown here. Now calculating V1, we need to first calculate the swept volume. We have a straightforward equation and we get swept volume as shown here, and the clearance volume is of 4% to that of swept volume. Therefore it comes to 3.77 10 to the power of minus 4 meter cube. Therefore the total volume, that is V1, is a sum of the swept volume and the clearance volume, which comes to 0.0098 meter cube. Now the question comes how to calculate V4. That can be calculated using the equation as shown here. So moving further, we have the equation here in place. Rearrange the equation, calculate the value of V4. Other parameters are known to us, therefore V4 comes to 0.00145 meter cube, and using V1 and V4 we can express the effective swept volume, and plugging in the values we get V1 minus V4 as shown here. These values can be plugged into the free air delivery equation, and therefore we get free air delivery as 0.00775 meter cube per cycle. Now calculating the overall volumetric efficiency, which is, we have the equation in place. We calculate free air delivery from the previous step, and we have swept volume, and the overall volumetric efficiency comes to be 82.2%. Further, indicated power, we have the equation in place, and the swept volume is effective swept volume is known to us, and pressure ratio is known to us. We plug in these values into the equation, and to express the work done in terms of time, we have to invoke the time factor in terms of RPM, and we get the indicated power as 17.5 kilowatts. So with this we have come to the end of today's lecture. Thank you for your attention. In case of any queries, please feel free to contact me on the following email ID. Please refer to the reading material as shown here. Thank you.